Hey guys, uh, in this lecture, we're gonna start a new topic, implementation guidelines. Let's see what we got for today. So, to implement a beautiful software, first we need to design a beautiful software. This is something that we have learned since the beginning of the semester. We mentioned this, many times. So, we mentioned a lot of design guidelines so far, all right? And this was our intention because we want to create a software that will be alive for a long time, all right? And in this regard, we need to implement it beautifully as well. And this is the goal of this lecture. Let's start with the story of fault and failure. So, sometimes to track down the bugs is very hard. You know why? Let, let me show you in a picture. So, let's assume that this is some objects of your software, and these objects are calling each other at runtime, right? And let's assume that something happens here. Okay. Now, if your program cannot catch this fault very close here, then what would happen? Maybe this fault causes a failure somewhere else. Let's say here. And as you see, the fault happens here and the failures happen here. And there are some, distance between these two. And these kind of bugs are very hard to track down. Okay, so what would be our goal here? So one goal of the design and implementation will be to put the to write or implement the program in such a way that if something goes wrong somewhere, the failure should be appear itself very, very soon. All right. So this would be a general strategy of implementation. To follow that strategy, we have several options. One of them is programming by contract. What does it mean? Let me start with a code review example. Let's say we are, reviewing a code like this. So, do you see any problem here? You can pause the video and try to understand and find an issue that I am looking for that. So, okay. So what would happen if the caller of this method, this is a public method, right? And probably some other classes will use this method, right? So that caller of this method could be yourself or could be thousands of other developers. So let's assume that you are not the only caller of this method. Let's assume that we have the worst case, which is this method will be called by another developers. Then what would happen here if the caller pass a null value here, right? So if this happens based on this code, you know that what would happen here. So because the b foo is a null value, so invoking any method from out of there, it will throw an exception, right? So And that's a very familiar and famous exception, which we call null pointer exception, right? Now the question is, the very important question here is, whose responsibility is to prevent this? Should the code implementer do something to prevent this? Or the caller of the method should do something, right? Or let's say they should have a contract between themselves that you know that will specify the responsibilities of each party. Which one is the best choice? What do you think about this? So in this section, we are going to talk about this part, right? First, we clarify what the contract is between the implementer and the caller, and then we will give you some examples that how to do that, right? So we focus on the third one. How the implementer and the caller of a code should communicate with each other. So definitely we would need a contract between these two, right? So one party of the contractor will be the implementer of the code, and the other party will be the caller of the code. And this contract can be defined as a set of preconditions, a set of postcondition, and a set of class invariants that I'm going to talk about each one separately. Let's start with the precondition. What is precondition? So precondition of a piece of a code, let's say for example a method in Java method, is a condition that must be true right before executing the code. What does it mean? It means that the implementer of the code will promise that if you provide these preconditions, I guarantee that the code is working, will work fine. All right, so this is the the meaning of preconditions, and this is a part of the contract between the implementer of the code and the caller of the code, right? Okay, so let me get back to that our previous example and see how we can document these preconditions. Okay, so here is the code that we have seen before, right? We have a method do something, and we are passing a parameter here, right? And this parameter should be not null, as we saw before, because if it is null, then here, invoking a method from the null will throw an exception, Java exception. And that exception, yeah, we know that it's a null pointer exception. We talked about this. And how can we document this precondition? Here, here is the way that we document. So we put a tag here, precondition, and we explain that this parameter be foo should not be null. Okay, and of course, when we are putting this, you know, this explanation here, and you know that this will appear in the JavaDoc, JavaDoc utility can understand this portion as the document of this method, and we assume that's a very important thing. We assume that the caller of this code should read this documentation carefully, right? All right. So now maybe you are asking what would happen if this precondition is violated. right? We assume that the caller will read this portion, but what would happen if this precondition violated? Should the implementer of code do something? I mean, in addition to adding this precondition here, should he or she do something? Let's see how many options the implementer of the code has, right? So we can imagine two strategies from the implementers. So first of all, implementer can do nothing. What does it mean? The implementer can say, okay, I warn the caller by putting a precondition in the JavaDoc, and I assume that they should read it carefully. So one strategy would be do nothing, right? Regardless of what would happen during the execution of the code, do nothing. Definitely, it's not a good idea. It's a very bad decision. The other option or the other strategy would be, yeah, we should do a null check at the beginning of the code. Even though we mention a precondition, we need to, prevent the code from failing by putting a null check and sending a appropriate message to the caller of the code that, hey, you should not pass the null value into this method. So I would say definitely this is a better idea. This is a wiser decision. And up to this point, let me tell you something. In software engineering, we have a principle that would say always assume always assume that the color of your code is a rookie, right? And warn the color by precondition and also do some checking and assume that the color is a rookie developer and put the appropriate checking uh, during the implementation of the code. And this principle leads to what? Defensive programming. So this kind of programming is a very professional programming, and we call it defensive programming. What is post condition? I'm sure that after uh, listening to the precondition, you can guess what the post condition is. So post condition for a piece of code, let's say a Java method, is a condition that must be true right after executing the code and before returning to the caller, right? So, but this post condition is true provided that the preconditions were satisfied, of course, right? So, in other words, the implementer of the code promises that if you provide the preconditions, I promise that the code will be executed, successfully, and also these conditions, which they mention as a post condition, will be true. All right. Again, let me explain that through an example, our previous example. So this is our previous example, and you remember that we checked the null, we put the null checked here, but it's not our point right now here. Let's, and here is the precondition here. Now we want to focus on the post condition. So our first post condition is bfoo will not change. So whatever you pass here, uh, it won't be changed, right? And the second post condition for this piece of code will be this some type that I am, the implementer is saying, this won't be null value, right? So here is how we document our post conditions. Now let's see. Now let's see. Let's have a flashback about the JavaDoc utility that we talked before and see that how these new things that we added works with the JavaDoc utility. Okay, you remember, we mentioned that if there is an unknown tag in your code, JavaDoc, you know, just skips them, right? So unfortunately, the precondition and postcondition that we use in the previous examples are not valid JavaDoc tags. So we need somehow to introduce them to the the JavaDoc utility. So if you are using the command line to create your JavaDoc, you need to add this portion to introduce all of your new tags, right? So here is an example how we can do that. So you would say, for example, dash tag and precondition, and that colon, this colon, and this CM shows that you are adding this precondition to the constructors and the methods. So this CM means this, or instead of these two, you can add an A, which is all, right? And this precondition, whatever you put in this string, will appear as the name of this new tag, right? In the Java tag. Okay. And for the post condition, you need to put another tag. The whole of this, you should put the whole of this for the post condition as well. If you run the JavaDoc utility from the Eclipse, then you would need to put these two options. So whatever you have, so maybe you have more tags. So here we have preconditions and postcondition. You should put it somewhere that we call it extra JavaDoc options. And as I will show you quickly in a live demo. So let me bring up my Eclipse. So here's my Eclipse. So as you see here, we have the precondition and postcondition. And I created this class, to prevent this nagging. So what is the big foo here? All right, so let me run the Java util and see what would happen. So as you remember, we need to go to the export and then find the JavaDoc and go here. Nothing to change, nothing to change here. Let's run it. And you see, we got two errors here. And if you scroll up, you will see that unknown tag post condition, unknown tag precondition. And so since the Eclipse does not know it, actually Java util doesn't know these two, so definitely it won't show in the Java doc. Let's see one more time. Let me run the Java doc here. So here is the Java doc we get, and this is our foo. And as you see, the do something method does not show the precondition and postcondition. So what we are going to do is to add these two guys and whatever you have in your code, what I mean the code, the tags that you have defined. So we go here, and here the extra JavaDoc options, we need to add these tags and define the precondition and postconditions. Now if you run this, you see there is no errors. And if we browse and go to the foo, and you will see that preconditions and the post conditions are now is mentioned in the JavaDoc. Now let's talk about class invariant. What is class invariant? So far we learned that preconditions are those conditions that must be true before executing the code. Post conditions are those conditions that will be true after executing the code. Of course, provided that the preconditions are provided correctly. Now we have another thing here, class invariant. So let me, before explaining what the class invariant is, since the invariant is not a popular word, let me first define it. What's the meaning of invariant? So invariant is a condition that it should be always true, right? So when we are talking about class invariant, it means that it should be always true as long as the class, of course, the class node, the object, exists. So in other words, right after the creating the object, it should be true, and before and after any operation, it should be true, right? So probably the best way to understand and explain this is taking a simple example. Let's say we have creating my date class. My date is supposed to keep track of the day and hour information. So it's some kind of a simple calendar, right? So so here is some operations. This is the constructor which we instantiate the object. We pass the day and hour to instantiate these two, and also we have set day, and we have let's say set hour and so forth, right? I just want to explain the concept of the class invariant. Okay, so this class, which is a very simple calendar, uh, you know it it can store the day number and the hour number. So can I put the day, for example, 45? Definitely no, right? The day value should be less than 31, at most 31 day in a month. And how about the hour? Yeah, it should be less than 24. So what do you think that would be the class invariant here? So always after or before any operation in this class, we should make sure that the day is always between 1 and 31, and the hour is between 0 and 24. So this is called class invariant. Java provided some facilities to help us to to make the distance between the fail and failure very closer to each other. So we have learned that when a precondition is violated, the wiser decision would be to warn the color of the code somehow, as I say, as I show here. So we put some kind of null check here to act, appropriately before the code goes to a disaster reaction. All right, and so one of them is Java assertion, as I said. Let's see how we can use this, Java facility. So the syntax, the simpler syntax is to put this in your code, assert, and put a condition here. So if the condition is true, then the rest of the code will be executed. Otherwise, the code stops. Okay, so the alternative syntax would be adding an explanation here, which is usually a string. And if you put an object here, as usual, the toString of that object will be invoked. Okay, now let's see our code here. So we see assert, and this is the condition here, and we put a string here to show it. All right. Some notes about this assertion, Java assertion. The first note and the most important one is that assertion by default is disabled. And if the code contains assertion, it will be neglected, right? So if you want to enable that, you need to put this option in your command line or in the Eclipse, the JVM options, right? And the short form of this enable assertion is just EA. Okay, let me show you a really quick demo about this. Here is our previous example. So do something. I just added this method to be able to call this inside here. Okay, so this is our code, and I'm gonna add a caller of this method and show you how we can add the assertion. Okay, so first we need a main. So we go this way, and Eclipse create a main for us. And so I'm gonna call this foo. So it will be equal to new foo, and then foo we want to call this do something. Okay. Okay, so here I'm gonna pass the null value to show you how that assert works. Okay, so if you run this program, let's see what would happen. So I am passing null to here, and this guy is being invoked from a null value that it will throw the null pointer exceptions. Okay, so let's run this. Yeah, as we expected, there is a null pointer exception, and it's here, exactly here. Now let's add some assert here. It will say assert, and since it's Java thing, so it part of the Java library, it doesn't need anything else. So we would say bfoo is unequal to null, and then we add a message here. Let's say, for example, bfoo is null, right? And at the end, this guy. Okay, so we have an assertion here. Now let's see what would happen when we run this application. What happened here is, Java lang null pointer exception again. So what's going on here? So we put an assert here, but we are still getting the null pointer exception. Why? The reason is, as I said, by default, this assert is not activated. So when you run your program, all of these assertions will be neglected. How can we add that? So we can go to the, run configuration, and here you need to add the VM arguments. You need to add this EA or enable assertion and then run it. Now it's totally different, right? It's saying that assertion error and our string is being shown here. So of course the string should be more descriptive, and also we need to put some assertion in the program for debugging purpose, and when something is wrong that we cannot figure it out, then we enable the assert and run the program, and the program will show you what the problem was. Actually, this is a very simple application, simple program. Definitely, you won't have that feeling that for a big program. I mean, the feeling that you would have for a big program, a very complicated program, you wouldn't have for this simple program. Okay. Another Java tools is exceptions, Java exceptions, which is a big a story, but and I will cover it in detail later. But for now, we look at that very briefly as a Java tools that we can use to catch the errors for debugging purpose, right? So let's take a look at the code again. So here we can throw an exception like this. Instead of using the assertion, we can use this guy. So if bfoo is equal to null, then throw a new exception. And this is an exception that I will explain in the next slide, right? So in this case, when we use the exception like this, which is more popular, to be honest with you, it always be executed. It's not like the assertion that need to be activated or something like that. So we check the bfoo is equal to null, then we throw an exception, and also we would need to add this throws and the exception name, right? And if the bfoo is null, then Java stops executing the rest of this guy, and it will throw an exception. So whose job is to catch that? Definitely the callers, as I explain in the next slide. Um, so, and here is how we can uh, document the throws. All of the throws can be documented like this, and it will be beautifully will be depicted in the Java documents. Okay, so before going further, let me uh, tell you some notes. Yeah, exceptions are just classes, Java classes, that I will explain them later. And also, as we said, it's the catcher. I mean, the caller of the code responsibility to catch it. So Java, as you know, has some predefined exceptions, like the one that we saw, null pointer exceptions, but you can create your own ones. So this pre-violation exception that I throw in my previous slide is not a valid, I mean, predefined exception. So we would need to create it, and I will, talk about that later, how to create it. Okay. So here is our code again, and I will show you how we need to catch that, which I am sure that you are already familiar. So to catch that guy, we put this portion of the code that throws an exception inside the try and catch. Now we have two technique using the preconditions and using the assertion inside the precondition, or we can use the exception. Which one is more appropriate? So this is actually an engineering judgment decision. After a while, you will learn where to use which one. So, but as a rule of thumb, if you have a private method, using the precondition is okay, because the private methods are being called inside the class, right? But if it is public method, throwing exception is more appropriate. So just keep in your mind these two rules of thumb. In this section, we're going to talk about the hierarchy of the Java exceptions. Okay, so if we want to handle the exceptions efficiently, we need to have a feeling about this hierarchy. We need to know deeply how this hierarchy looks like. So at the beginning, we have a throwable class, and this throwable class it has two main subclass or children. So exception and the error. Okay. Uh, Even though this able is a postfix for interfaces, but here Java made an exception and use it for a class. Yeah, usually we don't like the exceptions, but yeah, it's fine. Yeah. All right. So we have now two children for this throwable, exceptions and error. Let's see each one in detail. So the error subclass of the throwable contains those exceptions that is usually out of our control, and they actually represent some fatal error in your application. Actually, not specifically your application. When your application is run, something else is happening. In that case, JVM throws this error. So it is totally beyond our control. Or when I say R, it means developers control. So, right? Okay, so here are some examples. For example, if there is a issue in the Java virtual machine memory, yeah, so for example, we are out of memory or something like that, so JVM throws this kind of exceptions, and they cannot be caught. Assertion failure. If you as a developer put some assertion somewhere, and if it fails, then the machine immediately stops and it throws a assertion failure exception. Okay, on the other side we have the exception subclass. So the exception subclass is the superclass for all of other exceptions that might happen in your application's runtime. So let's focus on now this exception guy. So here is a except part of uh, the hierarchy of the Java exceptions. You see here, yeah. So we talked about this error. Now these exceptions has some uh, subclasses. So the main one is the runtime exceptions, IO exception, class not found exception, and we have more. Yeah, it's just as I say, it's a very small part of the that hierarchy. Okay, so now let's focus on the exception. So overall, we have two types of the exceptions: checked and unchecked. Let's start with the unchecked first. Okay, so what is unchecked exception? It's an exception that are not checked at runtime, at the compile time, I mean. So they are not checked. So when you compile your code, the compiler won't check that exceptions. So let me take some examples. Yeah. For example, null pointer exception is a very famous exception that I'm sure that all developers, has seen this many times, more than the other exceptions. So null pointer exceptions happen during the runtime. If you pass an, a null to a reference that it expects an object, if you send a null, and if you use that um, reference to call something, then this null pointer exception will be thrown. All right. And this is not something that Java can check at compile time. That's the uh, issue. So another example is index out of bounds exception. You have an array and you are using, and if you reference a cell of that array that does not exist, then this exception will be thrown. On the other side, we have the checked exceptions. Checked exceptions are those that compiler can check them. And if you did not handle that exception, it will, let you know, and the code won't be compiled. All right. So how can we handle that? I assume that you already know. Either we need to put that specific part of the code among a try and catch block, or you need to throw that exception via the method throws clause. Okay. So one example is IO exception. When you are trying to open a file or something like that, or read for reading or writing, so when the Java compiler see that code in your application or software, then Java expect that you handle that, right? So that's why we call it checked. So compiler expect you, you handle that kind of exceptions. So IO exception is one example. Let's get back to our hierarchy again. Okay, so all of the subclasses of runtime exceptions, these guys are unchecked. Yeah, there are more. There are a lot of more here, but these are just an examples. And the rest of those exceptions, for example, IO exception, class not found exception, file not found exception, and etc., etc., all of them are checked. Okay, so since I assume that you know how to handle the exceptions in your previous courses, so here I just put, for your reference as a recap, Okay, so you see, we put our code that we want to handle it by try and catch here, and then we, as a sequence of the catches you see here, we can catch all of the exceptions that might happen. And at the end, we might put optionally a block for the finally for all of those things that needs to be run after running one of these catches. So in other words, if you have a code here and if it throws a exception, yeah, so that exception will be caught by one of these guys, and at the end, if there is a finally block, that piece of code will be run as well. So finally, block code will be run if the code catches something. If everything is fine and this code is healthy and no exception is thrown, so it just finishes here and continue with the other blocks. The finally part won't be run. All right. So now let me give you some notes here and some hints. The first hint is that if you mentioned an exception, uh, not only that exception will be caught, but also all of the subclasses of the that exception will be caught as well. Let me take an example. So here you put IO exception here, and you are catching that exception. But from the hierarchy point of view, IO exception has a subclass and probably more subclasses. I mentioned just one of them. So it means that this point, this note want to say that if anything like the IO exception happens, this will be caught here. If file not found exception happen, this IO exception can catch that as well. So if you put a parent class, exception class here, all of not only that parent will be caught, all of the the children or subclasses will be caught as well. So this is the point number one. Point number two, the order of the catches matter is a very important thing. So let me take an example here. So let's say we have exception class, we have IO exception, and we have file not found exception. So as you see, the parent is a wider concept, and this guy is, a little bit more restricted than this one. So this is a little bit restricted than the exceptions, and the file not found is more restricted one. All right. Based on the previous node, if you catch this guy, then all of these subclasses will be caught as well. So if you want to, write a clean code, then you would need to go in the reverse order. It means that first you need to catch the most restricted one. So this order is important. So first you put your catch with the most restricted one, and then the other one and the other one. So this is a very important point in handling the exceptions. The other note here is if some codes of the catches blocks are similar, you can combine them with the vertical bar like this. And this can happen for the Java 7 and higher than that. All right. So let me take an example. You see here we have exception number one, exception number two, exception number, let's say n. Yeah, we have multiple exceptions, but provided that the code is similar. So if you want to similarly to catch all of these exceptions for some reasons, then you can combine them with this vertical bar and you can create just one catch block. Okay, up to this point, we shined our knowledge about the exceptions, and we know the hierarchy, and we know, some very important notes about that. And now we want to talk about how can we create a new exceptions. Yeah. So definitely we would like the checked exceptions. Yeah. We don't want to put an unchecked exceptions in our code. It doesn't make sense. All right. So if this is the case, if you want to create, actually you can create a new unchecked exception as well. But since it is, very rarely happens, let me just talk about the checked exceptions. Okay, so if you want to create this a new exception and a customized version of the exceptions that you want to use in your application, then here are the minimum requirement that you need to follow. First of all, your class should extend the exception class. All right. At least you need one constructor. And this constructor should have one argument at least that is a string type. All right. And of course, that string type will contain the reason of this exception. So you need to, print something, say something to the caller of that. The developer or the user of the your application that something happened. So why this exception is happening? So that's why you need a message that should be a string type. All right. And also inside that constructor, you need to call the superclass constructor. Yeah, let me take an example and show you how it works. Okay, now let me bring up my Eclipse. And yeah, let me create a class. So let's say it's an exception class. So um, yeah, there is a new class, and the class name, let's call it, for example, illegal format exception. For naming the exceptions, we usually use the postfix exception for them. So this is a convenient, convention for naming the new extensions, new exceptions, right? All right, so the subclass, yeah, we can be lazy and just say, yeah, this superclass will be exception, and that's it, finish. Oh, you see here, it extends the exceptions. All right, so the only thing that we would need here would be a constructor, public, and it should be uh, the illegal format exceptions. And as I said, we would need one argument here. Yeah, let's call it message. And the other thing that I mentioned, we need to call the superclass constructor, and we know how to do that. Just say super and pass this message to that superclass constructor. That's it. So this is a minimum uh, exception, a customized user-defined exceptions. It is a minimum. Of course, you can have more uh, instance variable, you can have more constructors, you can have even more methods. Yeah, this is a regular class. But the only thing that we need to do, this was the minimum thing that I just explained, and these extend exceptions make this class as an exception, and Java knows that how to behave with this. All right. Okay, so now let me test this. So I'm going to create a new class to test it. So the class, let's call it, for example, my exception tester, something like that. Okay. Inside here, I would need a main class, a main method. And okay, so how can we test that? Let me create a fake method here. Its job is just to throw an exception. So let me call it public. And since I want to just call it, so let me make it static and no return type, and let's call it fake. Yeah, all right. And its job is just to throw uh, a new illegal, yeah, and let's pass a string here, for example, um, I don't know, a fake um, exception was thrown. Yeah, this is just for joke. Oops. Okay, so now it is, complaining. What's the complaint? Look at the complaint message. Unhandled exception. Yeah, we are throwing something, and this method needs to handle that, right? So I'm gonna put a throws in the method's definition. So we have add throws declaration, or yeah, rename. Yeah, those doesn't work. So I'm gonna put a throws here. So it means that whatever happened inside this method, you just throw that exceptions to the caller. It sends this exception to the caller of this exception. All right. Okay. So now if I just call this method fake, for example, yeah, now it is again complaining. Look at this complaint. Unhandled exceptions. Yeah. So so this guy throws an exceptions, and this method will throws it to the caller of this method, which is this guy. So here we need to handle that. We have again two possibility here. Either use a try and catch, or again throw it to the caller of this main, right? In this case, we want to handle that. So um, control one. So you have some possibilities here. Add throws declaration that will do something like this, but I want to surround it by a try and catch. Yeah, just uh, we can call it laziness, or we can call it just saving some time if I use the Eclipse to write this kind of thing for me. Okay, so now, yeah, before doing anything else, let me just run this. So this is the automated, created the code by the Eclipse. It put the print stack trace here. So the whole stack trace will be printed here to show you where the error happens, and it shows sequentially uh, which part of the code was called by which part of the code, and so forth. Let me run this and see what would happen. Run as a Java application, and it is working. Yeah, here you see. So the illegal format exception is the exceptions that we just made. A fake exception was thrown. This is our message, you see. This is our message, and also the stack trace of where they started. So this is, yeah, just click on that. It shows you that it happens here, and then click here. It shows that the color was this. So the sequence of the colors will be shown here, and I am sure you are familiar with this. But the point of this uh, demo was to show you how we can customize a new exceptions in Java. Okay, now let's get back to our lecture note. Uh, if if you don't like this, I mean stack trace, yeah, you can just print a nicer. Let me comment out this. Just, yeah, system out. You can just catch the message if you don't want to your user see something like this. Yeah, you can just so this parameter here, you can call the e and get message, for example, something like this. Yeah, so let me run this, and you see, yeah, this is a nice, this just show the message, the error message. Yeah, get message, this error message that we throw uh, here. Usually, we show a neat and clean message to the users, but if we want to debug the code, then we would need something like this print stack trace to be able to track down the bug where the issue happens, and it shows the sequences of the calling stuff, and we can usually figure it out. Anyway, so let me return back to our slides. So here is the examples I intended to develop illegal format exceptions, and here is the minimum requirement of the class that we just created. As I said, we can have more instance variables, methods, constructors. So this is the minimum one, and also how we can throw it. Yeah, just throw a new that exceptions, and this is the message that we need to pass. All right, so this is what I had for this lecture. See you guys in the next lecture.